All right, so we are going to find the perimeter and the area of this figure. Do you remember how to find perimeter? How do we do perimeter? Base times height is the area. So we're going to add up all four sides. All right, so I got one side is 10x to the fourth, and then these are all congruent. So you got 10x to the 1/4, and then 10x to the 1/4, and 10x to the 1/4. Is there an easier, more efficient way of adding up all four sides instead of adding them individually? Is there a more efficient way? Multiply it by 4. That might be a little bit more efficient. I mean, you can totally do it this way. Could have done it by the time I was done talking, but just want to remind you that multiplication comes from adding the same thing over and over. So what do we get for our perimeter? Nice, don't you? 40 x to 1/4, right? You just multiply the 4 and the 10 together, and you put the x to 1/4 with it. Or over here, if you're adding them, you add 4 times with the like term, x to the 1/4. And then Olivia, you said base times height is area, right? But since the base and the height are the same, can we maybe do it a little bit more efficiently? Instead of base times height, we can say 10x to the 1/4 squared. So that gives us 100 x to the kind of depth. What? 1/2. Yes. So 1/2. And it's multiplying our exponents, so you multiply 2 times the 4th, which is 1/2. All right. We're going to go through our notes. Some of the notes I'm going to skip over because I want to give you more time just to practice in class. I mean, I could certainly take up all 100 minutes just doing examples, but I'd rather you just kind of get into it and do some on your own. So I have done all the notes and I put them on Canvas. If you need more notes and you want to go in and copy any more down, they are all on Canvas. We're just going to skip around and do like a few of each time. So we're going to start with number 6. Number 6, we're going to multiply together square root of, or 6 root of 25 and the 6 root of 625. But I'm not going to multiply 25 and 625. I'm going to do it a little bit more efficiently. Think about 25 being a prime number raised to an exponent. What is 25 equivalent to? 5 squared. We're going to multiply that by 625, but I'm going to take 625, reduce that down to a prime number to an exponent. What is 625? 5 to the 4th. 5 cubed is what number? 125, right? And then when I multiply these, they're both under the 6th root, so we're going to do the 6th root of 5 squared times 5 to the 4th. And I'm going to use my exponent rules. So if I have the same base being multiplied, what do I do the exponents? So what base do I write? 5. I keep the same base, I add my exponents. Now, in my head, I am thinking this next step. I don't always show it, but in my head, I am thinking, taking this and writing it in exponential form, I'm taking 5 to the power of 6 to the root of 6. So 5 to the 6 over 6 is equal to 5 to the first 5. So we did all of that, and we didn't even have to multiply together 25 times 625. A little bit easier way of doing that kind of thing when you can reduce them down. I'm going to skip those. We're going to go to number 9. So number 9 is the 7th root. A on this assignment, for the stuff that we're doing today, I think it's okay if you need your calculator to calculate the 7th root of 384. I think it's okay today to start using your calculator again. If you type in or 7th root of 384, you will find out it is a decimal. Did you do it? It's a decimal, it doesn't go evenly. So that means we're going to just try to find something to the 7th power that goes into 384. 384 is a small number. I mean, relatively small. I guess whatever your definition of small is. But something to the 7th power to actually go into 384, it's got to be kind of a small number. Just to get you started. Did you figure it out? What is it? 2 to the 7th. Which is 128. 2 to the 7th, or 128 times what number? How many times does 128 go in? 3 times. So then we simplify 2 to the 7th and the 7th root, and we get 2. And we cannot simplify the 7th root of 3. So we get 2, 7th root of 3. So we're just simplifying that one. Okay, this one is important. You're going to maybe get stuck in your homework, and then you're going to come back to this because we started. We have lots of people ask. We're going to do an example just like questions that are in your homework. And then you guys have space to the right of that to like show work and stuff. I don't have space, so I'm just going to recopy it over here. That's all I'm doing right now is recopying it. Okay. When we have a cube root of a fraction, if we can reduce the fraction, we want to do it first. We want to reduce what's inside of the fraction first. Can we reduce 5 over 9? Okay, so instead, let's take the cube root of 5 and the cube root of 9 separately. Can we find the cube root of 5 or the cube root of 9? What? What's cube root of 9? No. So is this simplified all the way? Or is there something else I can't have? That's totally going on here. Can't have a radical in the denominator. So this isn't simplified all the way. What we're going to do, though, is we're going to make it a little bit easier to tell what to do. What I need to do is have a radical in my denominator that is like a perfect cube. And it's not a perfect cube. Like 9 doesn't have a perfect cube. I need it to be a perfect cube. In order to help me figure that out, I'm going to factor 9 to a prime number with power. What is 9 factored? 3 squared. We have to multiply, and it has to be a cube root that we multiply by. So that's the only way I can multiply these numbers together if they have the same root. So I need to multiply by something. Whatever I multiply by, I need the bottom to end up as a perfect cube underneath. Right now it is a squared underneath. I need it to say cubed underneath. What do I have to multiply by to make this cubed? Right now it's 3 times 3 over here. What do I have to multiply to make it 3 times 3 times 3? I need to multiply by a 3. A cube root of 3. When I do that, that is going to give me a whole 3 to the 3rd on the bottom. And then there's cube root of 15 on top. I want it to be the same power and root. Because if I write this as an exponent, if I write 3 to the 3/3, what do I actually get? I just get 3. And so then I got rid of my exponent, or my radical in the denominator. It's just a little different than when we had square roots, because with square roots, you can multiply them to the exact same thing, it makes it squared. But with like cube roots, you have to make sure you have 3 of whatever's down there. So a little side note on that one. Little side example. If I had something like the cube root of 3 on the bottom and I don't know, 7 on top or something. If I had the cube root of 3 on the bottom, what would I have to multiply by to rationalize it? What do I have to multiply by? I have to multiply by 3 squared so that I'd have a total of 3 on the bottom. So you have to just give it what it needs to make that total root when you're rationalizing. Okay, 11, we have done these before. This time we have a radical in the denominator, but it has friends. It's 2 terms. So do you remember what we have to multiply by? The conjugate. Good. So we're going to multiply the top and the bottom by 4 plus radical 5. Which is a binomial, so I put parentheses in. On top, we have to distribute the 1, but it's just a 1. On the bottom, we're going to FOIL. So we're going to have 16 plus 4 radical 5 minus 4 radical 5, and then minus 5. If you multiply by the conjugates, the same thing always happens. If you're multiplying conjugates, the center terms always cancel out. Always. And when you're multiplying by conjugates, you're always multiplying by a plus and a minus for that last term, so it will always be a subtraction. Always. If you're multiplying conjugates. So kind of like save you a little time. So we have 4 plus radical 5 on top. On the bottom we have 11, and that is as simple as it gets. So the next one, what would you multiply by? Try. So on top, how are we going to multiply 1 term times 2 terms? Distribute, right? So we're going to get the square root of 2 minus the square root of 12. On the bottom, we're going to FOIL, but they're conjugates. So I'm going to multiply 1 times 1. I'm going to get 1. My outer and my inside will cancel. I'll get a minus sign and then a 6. And we're going to simplify that a little bit further. We're going to have square root of 2 minus square root of 12. But square root of 12, we should already like kind of recognize that something happens special with 12. All right, breaks down. And then we have negative 5 on the bottom. Is that simplified? When we talk about simplification rules, is that simplified all the way? Why? What's wrong with that? Has to do with negatives. It's not necessarily that there's 2 negatives, but it has something to do with a negative. What can we not have? You cannot have a negative in the denominator. It's just a simplification rule. So what we're going to do is we're going to multiply the top and the bottom by a negative 1, which is like value. It has a value of 1. It just changes the appearance, changes all the signs. So on top, we're going to distribute. And I'm going to have a negative radical 2 and a positive 2 radical 3, but I am choosing to reorder those. You don't have to, but I'm choosing to reorder those just so I have the positive first. You don't have to. Yes?
If you could do that with number 12 and number 11, could you multiply the top and bottom by 5 and then 75 the radical to 5?
You're talking about number 11.
Yeah.
Let me go back. Can you multiply by what?
5 over 5. Isn't that just a little
You're talking about from the beginning or at the
No,
end?
at the end.
So you're talking about multiplying by 5 over 5?
Yeah.
Well, that will take us to make 20 plus 5 radical 5 over 55. Were you thinking it would go under the radical?
Or
Right, so to go under the radical, what would we multiply by?
radical.
Right, but if I multiply by radical 5, what happens to the denominator?
Okay.
Right. So that's as simple as it'll go for that one. Oops. How did I just do that? I don't know what's happening. Okay, good question. All right, next one. Look at 13. 13? Yeah, 13. I don't know. I didn't renumber these when I copied them all. I put a bunch of random things together, so sorry. There's kind of crazy numbers in orders, weird orders. Sorry about that. Okay, when we go to add things that have radicals, these are just like adding x's, where you can only add like x's that have the same exponent, the same variable. Here, we can only add when radicals have the exact same index number, that same root, and they have to have the exact same number underneath. So with this first one, we do have the same root, the same number underneath. So I can take -2 plus 40 of cube root of 5. So I'm going to just add my coefficients. I'm going to get 38 cube root of 5. That's just like terms. And then we go over to number 14. We do the same thing with 14. Okay, so the 1/4 power is the same thing as the 4th root of 1250. And the 4th root of 32. Can I subtract those? They're both 4th roots, but they don't have the same number underneath. So you cannot subtract them as is. But maybe they simplify. So does 1250 have something we can break down out of it? Does 1250 have like a prime number to a power? What makes 1250? This is where you could use your calculator. What makes 1250? Okay, so those aren't prime numbers. So let's factor it down even more than 25 times 50. I mean, it is 25 times 50. Well, let's make it prime numbers. 25 is 5 squared. What's 50? 25 and 2, and 25 is 5 squared. So what is 1250? 5 to the, how many 5s go into 1250? How many 5s go into 1250? Oh, you mean 5 times 250? And then take out another 5. And then take out another 5. And then take out another 5. So 5 to the what goes into 1250? 5 to the, I don't think so. Where's your calculator? 5 to the what?
We're trying to get to 1250.
Yeah. I mean, it's not gonna just be 5 to the.
Oh.
5 to the what? 4 multiplied by what number? 2. That's the prime factorization of 1250. It's 5 times 5 times 5 times 5 times 2. It's like when Eric originally told me 25 times 50, I broke those further down to 2 5s over here, 2 5s over here, and a 2. So that's 4 5s total and a 2. Okay, minus. Now we have a 5. We're going to do the same thing with 32. We're doing the fourth root, but let's take 32 and factorize it. Take a prime number to a power. What goes into 32? What makes 32?
60.
I want to hear prime numbers. 2 to the 4th times 2, or 2 to the 5th.
Oh.
But you know what? You totally read my mind, because I'm totally going to write it as 2 to the 4th times 2. It is 2 to the 5th. 32 is one of those 2 powers, 2 to the 5th. But I'm totally writing it as 2 to the 4th times 2. That's kind of funny you said that. Yeah, totally. You know why?
Because it's the fourth.
Because we want to take the 4th root. So my next step is I'm going to take the 4th root of 5 to the 4th. I'm also taking the 4th root of 2, but I can't. Over here, I'm taking the 4th root of 2 to the 4th. But I'm also taking the 4th root of 2, but I can't. So we've got 2 multiplied by the 4th root of 5 to the 4th is 5, multiplied by the 4th root of 2, because I can't do anything with that. Over on the other side, I've got 5, and then the 4th root of 2 to the 4th is 2. And then we still have a 4th root of 2. So we're simplifying that down. Now what do I have? 10, 4th root 2 minus 10, 4th root 2. The same radical, same root. So can I subtract them? What do I get? 0. Yeah, all that for a 0. I mean, you can't look at that and say you knew that was 0 to start with, though. All right. This stuff takes a little bit of practice. Okay, the next little piece of notes, I'm just going to kind of explain with an example. And this, I know I did it in Algebra 2. I don't know that all the algebra teachers went over this. Okay, so this may or may not be new to you. That doesn't mean if you had me, you remember it all. Well, probably not though, because we didn't spend very much time on this next thing. So this next thing could be new. So I'm going to explain with an example. Do you know what the square root of x squared is? Think it's x. You think it's x, okay. Let's do an example. Let's say x is -5. And let's plug in -5 for x. The square root of -5 squared is the same thing as the square root of, what's -5 squared? 25. What is the square root of 25? Is that equal to -5? So it kind of has to do with the plus or minus, but like you weren't putting the plus or minus in yourself because the radical was already there. So what it says in that little box above it is that the square root of x squared is the absolute value of x. It's the absolute value of x. And the reason, And the reason that is true is because of this statement right here. The square root of -5 squared is not -5, it's +5. So you need to say when you have a variable and you don't know what that variable is equal to, you need to know that when you square root it, it's going to be an absolute value. It's going to be a positive answer. If you don't care why, the only time you would need this, if you don't care why, the only time you would need this is when you have an even root, and then when you simplify it, you get an odd exponent. That's when you're going to need the exponent, or the absolute values. You have an even root, and then you simplify it, and you get an odd exponent. Okay, that's when you're going to need the absolute value. Question A, we're going to do the cube root of 64 y to the 6. I'm going to separate this. I'm going to think about the cube root of 64 and the cube root of y to the 6 separately. Do we know the cube root of 64? 4. It's 4. This one, if you're not sure, you can change it into exponential form. Y to the 6 power over a root of 3. That gives me 4 y to the y to the second. 6 divided by 3 is 4. Do I need absolute value on the y? I don't need it on the 4. Do I need it on the variable? No, because it starts as a odd. We don't need it. Or it comes out as an even. We don't need it. So that one does not need absolute value. Next example. Next example, we've got the 4th root of x to the 4th divided by y to the 8th. So I'm going to look inside of my root first and see if these simplify. Do they simplify inside of the root? They don't. So then I'm going to do the root, 4th root of x to the 4th, and I'm going to do the 4th root of y to the 8th separately. So we're going to think x to the 4 over 4 and y to the 8 over 4, power over root. What am I going to get? X over y squared. Do I need absolute value? Yeah. Do we start with an even root? Do either of those variables have an odd exponent? The x. So the x gets absolute value. The y doesn't. The x does. All right, let's do A. So A has a bunch of variables in it, and it has a number. I'm going to look at the number and each variable separately. So I'm going to look at my 5th root of 4. Is 5th root of 4 like simplify it all? Is there a 5th root that goes into 4? A to the 8th. I'm going to change that to exponential form. A to the power of 8 over a root of 5. Does 5 go into 8? Not even. Does it go at all into 8? Does 5 go into 8? It does. If we're thinking like mixed numbers, how many times does 5 go into 8? 1 with a remainder of 3/5, right? So this is the same thing as a full 8 and a remainder of 3/5. That's 1 and 3/5. We're breaking it down, so we're finding the perfect 5th roots that are going to pop out of the radical. There's 5 A's underneath, and then 3 more left over. Did I make that clear? I don't know if I made that clear. So like the exponent, the power, there's 5 of them, and then 3 more left over. And then the full 5 come out. Same thought process with the b. We've got b to the 14 over 5. Does 5 go into 14? At least once. Yeah. How many times does 5 go into 14? 5. So we're going to have like 10 of those b's. B squared is going to come out. And then what's left over? 4/5 left over. And then the last one is c to the 5/5. And that's just going to simplify to like 1c. So everything that has an exponent that reduces all the way, like this one, and this one, and this one, all of those that reduce evenly, they come out of the radical in our answer. So we'll have a to the 1st we'll have b to the second, and we'll have c to the first. Everything that did not reduce is like left over under the radical. We'll have the fifth root of 4, we'll have a to the third, and b to the fourth left under the radical when we're done. So you're pulling out powers of 5. Yes.
Why didn't why since a, why is it just a to the third, not like the 3/5?
Because I put it back into radical form, so I took the bottom number and made that the root,
Oh, okay.
and then the 3, the top number is still the power.
All right.
Thank you for asking. Other questions on that one? All right, so question B. That's another kind of important one. People have a lot of questions on. So question B, can I reduce an x with a cube root of a y? Y's. I can't reduce this, right? Cross out x's and y's. So this looks like it would be simplified, except for we have a radical in the denominator, so we're going to have to rationalize it. We have to multiply the top and the bottom by some cube root. We want the bottom to be a perfect cube root. Currently, I have 8 y's down there. I'm not going to be able to make it into a 3. So what I'm going to do is I'm going to make it into a power of 3. So 8 plus how many more gives me something divisible by 3. If I add one more, I'll have 9 of them. And that's divisible by 3. So I'm going to add or multiply one more y. That's going to give me on the bottom the cube root of y to the 9th. And if I have the cube root of y to the 9th, that is the same thing as y to the 9/3. So we have x cube root y over y to the 3rd. Do I need absolute values? Did I start with an even root? No, so I don't need absolute values. Okay, I'm doing all right. I'm almost done. Can you do A? Can you do A? When you add, what's that mean squared? You're adding.
Only 2 minutes. I gotta go back and I gotta go back through and wait for it to down.
Good. That's right. All right, so if we have 5 of square root of y, and we have 6 of square root of y, then we have how many square root of y? 11 square root of y. Just like terms. Got 5 of something plus 6 more of that exact same thing, and we've got 11 of them. You guys remember the distributive property? Or factoring, you remember factoring? You see how they both have square root of y? You can factor out the square root of y and write 5 plus 6 and get 11 square root of y. That's another way of doing it. Just like terms. Okay, when you go to B, are they like radicals? They're not like radicals. So we have to simplify them, and hopefully they will magically become like radicals when we simplify them. So let's look at the first one. Got 12, we have the cube root, and we have 2 times z to the 5th. but I want to simplify. So any powers of 3 I want to pull out. So when I have z to the 5th there, I'm going to do z to the 3rd and z squared. So I'm separating z to the 5th by putting 3 and 2. And then I can simplify the cube root of z to the 3rd. So you got 12. What's the cube root of z to the 3rd? Z. And we have left over the cube root of 2 z squared. We look at our other one, we have a z outside. It helps a lot of people to make the z's with the extra line in it so they don't look like 2's, especially when we're doing 2's and squares all in the same thing. So you know that's why I put the line there. Okay, over here, in order to be able to subtract them, my radical has to be exactly the same. So is there a way to simplify 54z squared so it ends up having like a 2z squared left? What times 2z squared is 54z squared? What's the number? 27, yeah. 27 times 2 is 54. And then 27 is a cube. So we do minus 3z cube root 2z squared. We simplify it and we have the exact same radical. So if we're factoring out that radical, we're adding together or subtracting 12z minus 3z with a cube root 2z squared. So we have 9z cube root 2z squared. So I would suggest that if you're trying to figure out how to break down one of them, you look at what's left on the other one, and that helps you know what to kind of break it down to be. Question? Okay, we're only doing a few more. So a couple more, 3, 4, 5 more. This one, we're just going to do number 15. In this section, let's just do number 15. I mean, you can do more. You can check my answers if you did more, but just 15 right here. Okay, when we talk about how many terms there are, on top there's no plus or minus signs, on the bottom there's no plus or minus signs. So you can just divide stuff, because it's just one term over one term. So we're going to just divide 6 over 3, what do we get?
So do they only need to have the common stuff when you're adding or subtracting?
Yep. You just have to have like terms when you add or subtract.
Okay.
Yep. You always thought our adding or subtracting was the easy part. It's actually harder. Has more rules. So 6 over 3 is 2. And then we've got x's on the top and the bottom. So the rule is if you have the same base, what do you do to their exponents when you're dividing? If you have the same base, what do we do to the exponent? What do we do? We subtract them. Thank you, Brady. So my exponent on top is x to the first, and then on the bottom is a half. Same thing with the y's, y to the 3/4 minus a half. So when we are dividing like same bases, then we subtract the exponent. So now we have 2 x to the 1/2, y to the 1/4. Do I need to put those as square roots and cube roots or fourth roots? Do I need to write them as roots, radicals? I do not, because the original question has exponents, so I'll put my answer in kind of the same form. So I'll just stop here. Stop right there. And then look at 15. So 15 starts out the way a lot of our, the assignment that you were supposed to do, that I showed you my answers for, but you didn't write down my answers, we didn't grade it yet. This one starts out that way. You see what all three radicals have in common? They're all the fourth root. So we can pull that fourth root out and make the whole thing just the fourth root. The reason why I want to do that is because when it's a fraction, I can actually reduce some of it. I can simplify some of it up and down. I can cancel some stuff out. What can I cancel out? Yes, but that's not canceling, but yes, we're going to do that too. But what can I just like cross out up and down, reduce the fraction inside? Something on the top and something on the bottom I can. Yeah, how many X's? 2. All right, cross those out, and then I'm going to make that to the 34th power. All right, we're going to reduce those X's. And then, Annie, you were saying that 81 is 3 to the 4th. Just like 16 is what? 2 to the 4th. So what do we have now? We've got 3 on top. On the bottom, we have 2, and then we still have a 4th root of x to the 34th. So we pulled the 81 out, made it 3. Pulled the 16 out, made it 2. We canceled 2 of the x's. This is where we are so far. By the way, you may work ahead and totally do it a different way than I did it, but still get the same answer. There are different ways of doing this. There are different orders that you can do this. Okay, so at this point, I need to simplify down here. What should we do? Any ideas? Does 4 go evenly into 34? What does 4 go evenly into? Bigger than 34. 36. So if I made that into 36, 4 would go evenly. So can we rationalize? How many more x's should I give it so it becomes 36? 2 more. If I give it 2 more x's. So now on top I have 3 times the 4th root of x squared. And on the bottom, I have 2 4th root of x to the 36. I guess we could have done that earlier. It's like the exact same thing we had earlier, but that's okay. So on the bottom, if I simplify x to the 36 over 4, then I have 2, and what's x to the 36 over 4 become? X to the 9. Okay. There's one more tiny little thing that does come up in your assignment. There's one more tiny little thing we can still simplify. It's on top. The bottom's fine now. Something small on top we can do. If I rewrite this as exponential form, it becomes x to the what? 2/4. Well, that's the exact same thing as x to the 1/2. So since that's simplified, I'm going to simplify this. I'm going to write it as 3 square root x over x to the 9th. And I got that square root because x to the 1/2 is a root of 2. So you can simplify these if they're both even. You can reduce them. Yes?
Did you cancel out the 2 in the denominator? Or?
No, I just didn't write it. Thank you. It's still there. There you go. That would be our final answer right here. So I know I'm going to put some stars there because I know that this part right here is in your assignment where you'll have like something to the 2nd power, but then the 4th root, which reduces. I know that's in your assignment. Okay, the very last page, this right here. Okay, we're going to be solving equations on this last page. We're solving equations, and to solve equations, the first one is totally worked out for you. I just want to show you what they're doing. From the first line to the second line, they're just making both sides have the same base, the same big number, the same base. So we took 27 and rewrote it as 3 to the third, because they're equivalent. So we're taking our numbers and doing prime factorization. Then, from this step to the next step, what happened to that same base? What they have here is they have 3 to an exponent is equal to 3 to an exponent. So the exponents have to be exactly the same. So what they did here is we just set the exponents equal. Because if you have the same base, the exponents have to be the exact same. They have to be equal. And then from there, you can just solve to n minus 1 equals 3, so n is 2. Just solve that from there. So our goal is to get the same base and then set the exponents equal to each other. So look at number 1. We've got 2 to the n. 2 to the n. On the other side, we have 4 to the third. So they have the same big number, same base. Did you know? Normally, most of the time, we're going to take it down to prime factorization. Sometimes it's easier to not do it that way, but most of the time it is easier to make them both the prime number. So we're going to change 4 into 2 squared. So we'll have 2 to the n equal 2 squared to the third. And when you do power to power, you multiply your powers. Power to power, you multiply them. So we have 2 to the n equals 2 to the 6. So do we have the same base? So we set our exponents equal, n equals 6, and that's what n equals. And you can check it by plugging it back in, it should work. Next one we're going to do is 4. So 4, what big number, what base should we make both sides? 5. So this side is going to be 5 to the third. The other side has 5, but it's got it twice. We have to multiply it together. So when we're multiplying the same bases, what do we write and what do we do the exponent? So we're multiplying the same bases, then what base do I write? 5 to the n times 5 to the fourth. I write 5. I write the same base. And then what do I do to the exponents when I'm multiplying bases? I add them. When you do that, now you have the big numbers the same, so we can set our exponents equal. N plus 4 equals 3. So n is -1. Okay, the next one we're going to do is 5. The last one we're going to do is 5. How about that? The last one we're going to do together is 5. So number 5 says 2 to the n, that quantity to the n, equals 4 to the 8. What should our base be? 2. It should be the prime number. So I'm going to change this 4 into 2 squared to the 8. So that's going to be 2 to the 16. Remember when we do power to a power, we multiply. So right here, we're doing power to a power. So I'm going to have 2 to the, what do I do to my exponents? When I do power to a power, I multiply them. So it's n times n. N squared. So we'll have an exponent with another exponent on it. So we've got 2 to the n squared equals 2 to the 16. So we have the same basis, we can write n squared equals 16. When there's a squared, how many answers am I going to get? So how do I get 2 answers? Plus or minus, right? So we're going to square root, we're going to put plus minus, and there's 2 answers. So we survived, we made it through. We'll put our assignment up, and we'll take a brain break, okay? Some of us need to get up and do some, I don't know, some desk or something. And get up out of our seats. I'm just gonna put up the assignment. The assignment is, you're gonna finish that worksheet number 2 that we were working on last time. But you can take off number 29 and number 30 because they're total repeats. They're on there twice. So you can just scratch out number 29 and 30. And then you also have to finish the last page of notes that we were just working on. Those 14 questions, we just did 3 of them, so it's just 11 questions. And that's your assignment for today. Okay?